Hello guys. Today we'll be seeing about how to fine tune your Llama 2 on your own dataset. Okay, so we'll be fine tuning this in Google Colab itself as usual. So let's jump on into the fine tuning right now. Okay, so here if you see, we have Meta Llama 2 7B HF, which means Hugging Face. Okay, so recently Meta released Llama 2. There were different varieties which was released. Okay, so that can be seen here. They have released different versions, out of which we have choose Llama 2 7 billion model. Okay, so here if you see, here it is written you have been granted access to this model, right? So to get the access, what you need to do is first go and fill this form. Okay. So your name, first name, last name, email ID, country, and then followed by your organization or affiliation, which means if you are a student, you can just enter student as well. Okay. So once you've done that, when you come here, like I said, you should have an account to have some tokens, right? So similarly here also you need an account. There it will ask something like need access or some button will be there. Okay, so once you click that, within a day you will get an access. Okay, you will get mail from Hugging Face itself stating that you got access for Llama 2. Okay, so once that is done, then only you can do this. Okay, so I have got my access. Okay, so let us start implementing the fine tuning. Okay, so for this, what we'll do is we'll be using something called QLoRA. Okay, so in our previous chatbot video, which is the first video of NLP projects playlist, we fine-tuned Flantify using LoRa, right? There we spoke about it very briefly. Um, Here also we'll be using LoRa, but not just LoRa, we'll be using something called QLoRA. Okay, so what QLoRA stands for is that here you can use the LoRa technique itself to fine tune your models, which is quantized. Okay, so here what we'll do is we'll be quantizing our model to 4-bit. What does that mean? So usually we have data types, right? Like float, int, or maybe string. Okay, so for float and all, there is float 64, float 16. Okay, for int, there is int 32, float int 64. Okay, but what we'll do here is we'll be training it in 4 bits. Okay, like I said 16 and all, right? So here we'll be training it in 4 bits. So it will be drastically reducing your model, but the theory in the research paper states that we'll be receiving almost the same accuracy of other model. Okay, it's base model. So for an example, there is this model called Guanaco. Okay, so Guanaco leaderboard. Was it here? Let me check. So here you can see there is a model called Guanaco, right? This was a quantized model to 4-bit. Okay, these are all not quantized, neither these, but this is a quantized model, which shows that you can do your training even in quantized way. Okay, so we'll also be doing something like that. So for PEFT, for using LoRa, we'll be using a library called PEFT. As well as for our trainer, we'll be using something called SFT trainer, which is supervised fine-tuning trainer from a library called Transformer Reinforcement Learning. Okay, so I'll make separate videos, a playlist actually on PEFT and TRL very soon. Okay, because there are a lot to explore in this. So here you will have something like reward trainer, PPO trainer, DPO trainer. There are a lot of different things. Okay, so DPO, PPO, reward trainer, everything are there. I'll cover everything in a separate playlist. Okay, because even if you see ChatGPT was done based on reward training, which use PPO. Okay, so yeah, we'll start with the fine tuning now. So for now I'll write it in VS Code and then I'll paste it in Google Colab. Okay, so yep, we'll start now. So yeah, now let's start with the import. Okay, so here there are some dependencies. Okay, so what are those? I'll just say in a minute. So I'm just commenting it here so that we can do it a pip install in our Google Colab. Okay, so yep, now let's start with this. Okay, so now first we need to do some imports. Okay, so we'll start with import torch. Okay, then we'll have dataset loading. So from datasets import load underscore dataset. Okay, then we'll need LoRa. Okay, for that we'll use LoRa config. From peft import LoRa config. Then from transformers we'll need auto model. Okay, auto model for causal LM, causal language modeling rather. Okay, then we'll need auto tokenizer. Okay, after that we'll need something called bits and bytes config. Why it is needed I'll say in a minute. Okay, so after that we'll need training arguments. Okay, so now from TRL we'll need SFT trainer. Okay, now our imports are done. Now let's start with creating a function. Okay, maybe we'll say finetune llama v2. Okay, so here first what we need to do is we need to load the dataset. Here what we'll do is we'll use a dataset called, I'll go to Hugging Face. Okay, open assistant, let me try Guanaco. Yep, we'll use this dataset because this was the dataset in which Guanaco was trained. Okay, so let me put it in our collab. Okay, we have it here. So we'll need only train, so we'll take the train alone. Okay, so yep, now what we'll do is we need tokenizer and then followed by a config file which is needed for quantizing the model. Sorry, so first we'll load the tokenizer. Okay, tokenizer equal to auto tokenizer dot from underscore pre-trained. We need the name. Okay, so I'm just using it here. Okay, so we also need to set the tokenizer EOS token as not EOS pad token as tokenizer dot EOS underscore token. Okay, so after this next we need to load our config file. Okay, we'll have it as bnb underscore config. which is equal to bits and bytes config. So we need 4-bit. Okay, so we'll have that as true. Load in 4-bit equal to true, and then quantization, BNB 4-bit quantize will be NF4, which is called as normal float. Okay, and then followed by this we'll be needing something called BNB underscore 4-bit compute D type, which will be float 16. Okay, so we'll need float 16 because it is kind of a generalized data type for any quantization. Okay, but there are some other types as well, some like you can specifically use bfloat 16, but for that you will need some GPUs which is supported by uh, AMP. Okay, um, next we'll need BNB 4-bit double quantization, which will be true. Okay, so next followed by this we'll be loading our model. Okay, model will be equal to auto model for causal LM dot from underscore pre-trained, sorry, first we need to enter the checkpoint. We have it here. Okay, we'll paste it here. Next we need the quantization. I think I imported it correctly, right? Auto model for causal LM. Let us check anyway. Yep, I just used an L. That's why the problem was. Quantization underscore config will be equal to BNB config. Okay, so this is why we needed the bits and bytes config, because we need to quantize the model to 4 bits. Okay, next we'll be using something called device map, which will map our device to CUDA device. For now you need CUDA to fine tune your model. Okay, so here we'll map everything to 0. Okay, so now our model is loaded. We also need to do another 2 steps. Okay, model dot config dot use underscore catch equal to false. Okay, so this is to make sure that it is in training mode. Next we'll do model dot config dot pre training underscore TP equals 1. This pre-training underscore TP was created by Meta itself, okay, to ensure that you will get similar results from uh, your pre-training. Okay, so the fine tuning will be similar as pre-training. That's why they gave this. Next, what we need to do is our LoRa config. Okay, for that we'll have a variable called peft underscore config, which will be equal to LoRa config, and here we'll need first we'll need r equal to 64. I made a detailed video on LoRa config, how to use it. Okay, I'll make a video like that, but to have a basic explanation, please do check out our chatbot video of fine-tuning Flantify uh, to make a chatbot. Okay, so there I have given a base idea of how LoRa works. Okay, so here we need LoRa alpha as 32. Next, a dropout, we'll have it as 0.05. There is no need for any bias equal to none. Okay, then finally we need task type, which is causal underscore LM. Okay, so that is done. Next, we need to import our training arguments. Arguments equal to training arguments. Okay. We have separation. Okay, so what all do we need now? We need an output directory which will be equal to maybe llama2 fine tune chat bot. Okay, followed by this we'll need batch size per device. Train batch size will be 12. Okay, so I have experimented it in Google Colab, so this will work. Okay, gradient accumulation steps will be 4. So next we'll be using some different optimizer today, which is called paged underscore adam underscore w underscore 8-bit. Okay, this is a specialized optimizer created for QLoRA. Okay, so these are all called page optimizers. There is adam w at 32-bit, there is 8-bit. Okay, there are different types. Okay, next we'll have our learning rate, which will be 2e minus 4. This was from their paper itself. Okay, from llama itself. Llama was using 2e minus 4. Okay, next we need lr scheduler. We'll use linear. Okay, then we need save strategy, which will be epoch as usual. Okay, so next we need logging steps. We'll take it as 10 because not we are not gonna run it for so long. Okay, so num underscore train epochs will be 1, and then followed by max steps will be let's take 20. Okay, we are just gonna run the model for 20 steps, so we can't expect any results. Okay, we are just showing how to do. I'm just showing how to do fine tuning in Google Colab. But what you can do is you can just remove this max steps. Maybe set max steps to some arbitrary value like 1 lakh or something like that, and then you can run the model. It will work for the full data set. Okay, fp16 equal to true to run the model in float present 16. This is for mixed present training. Okay, so what it will happen is the model will be trained in float present 16. So next we'll be having push to hub, which is our final parameter. We need to push to hub, right? So that is enabled as true. Finally, we need to call our trainer. So trainer will be equal to sft trainer. So what is this sft trainer? This sft trainer is called supervised fine tuning trainer. Okay, so this is created by Hugging Face itself in a different library called TRL. Okay, so yep. Now what we'll do is we need to take our model for this, which will be model itself. Then we need train data set, right? So for that we'll take data. Okay, followed by this we need our config. We'll take that. Okay, followed by this we need something called dataset text field. Now for this what you need to do is, so here we'll take the dataset. So here the column name is text, right? So this is your dataset text field. Okay, so now let's enter that text. Okay, so followed by that we'll need training arguments and tokenizer. So training arguments will be equal to training arguments and tokenizer equal to tokenizer. Finally, we'll be sending a value called packing. Okay, so what it will happen is it will try to pack the sequences. Okay, for now we'll set it as false. Okay, about this SFT trainer or any other things we discussed right now, like QLoRA, everything will be a separate video. Okay, separate playlist will be there for PEFT and TRL. Okay, let's see if we can stick it on within 100 lines. Okay, so now this is done. We'll call if underscore underscore name underscore underscore equal to main. Okay, this is looking good. Okay, I guess it's fine. Okay, yep, left one trainer dot train trainer dot push underscore to underscore hub. All right, so this is good. Okay, um other than this, I think now everything is fine. Let me copy this. Okay, so next what we'll do is we'll go to our Google Colab. Okay, we'll paste it here. Okay, now this is a separate cell. Okay, connect. We need GPU runtime, so we'll just enable that. Python 3 GPU save. All right, so we'll give connect. So it is connecting right now. So it is getting initialized. So let's see if it is working right now. Okay, so it is getting installed. Yep, it is now installed. So let us run this. Okay. Oh no, I think we'll get an error. So before this, when you are doing it in notebook, like I said, we need to log in to provide a token. Okay, it is needed. Import notebook underscore login. So if you are doing it in your local, right, then you have a command called Hugging Face hyphen CLI space login. Okay, just type it and the similar process will happen. Okay, before executing your file. So for token creation, please refer to our chatbot video, first chatbot video. Okay, so this is done. Now we can execute it. Name underscore C is not defined. What happened? Maybe we'll restart the runtime. Okay, this is copy, pasted, login. Okay, we'll have it as a separate new cell. Let's try to run this now. Okay, now it is getting imported. Yep, here you can see the dataset is getting downloaded. Okay, so guys, until the model is getting trained, if you like this video, please click the like button. If you haven't subscribed to our channel, do subscribe, because there are lots of good contents which is being loaded up. Okay, there are lots of contents which is coming up in LLMs, and I'm trying to cover everything. Also, I'll be doing some traditional NLP videos, okay, along with some transformers videos such as BERT, okay, BERT and T5. I'll be covering a lot of things in NLP. Also, I'll be doing some videos in machine learning, and some research papers also will be covered. So, to not miss any of these, please do click the subscribe button. Okay, and if you have want some videos from my side, do mention it in the comment section so that I can make videos accordingly. Okay, so now the model is getting loaded, so we'll have a look here. Okay, so here you can see the model is now downloaded. Now what it is happening is it is loading that those checkpoints. Okay, so it is a huge model. Here you can see it is having around 12 gigs. Okay, no more, maybe 12.5. Yes, 12.5 gigs of storage. Okay, so that's why it is taking some time. Okay, so yeah, for me, my the power got cut. So we are resuming the training now. Okay, so there were two changes which were needed. First, for faster training, I changed the max steps from 20 to 10, and there is no parameter called training arguments. It is args. Okay, so I'll be obviously sharing the code so we can use the code. Okay, so it is now loading again. All right. Yep, it is loading. It's 3.6 right now. Okay. Now it is starting the training. So here you can see, right? The GPU consumption is getting increased. Okay, code out of memory. But it is 13.4 out here. Okay, let's have it to some smaller size, like 8. Hope it will get trained right now. So here, again is getting loaded. Do we need to change anything? I don't think so. So yeah, let me see you guys once the training is completed. Okay. So yeah, guys, finally you can see that the training is started here. We ran into a very important mistake here. I just left max sequence length parameter, which is very important to set. So I set it to 512. Okay. So we can also set it higher, but make sure that the batch size is lesser. Okay. For now it is an 8, but you can also push it to 12 because it is only 10.6 which is consumed. Okay. So yep. So it will take around 5 minutes it seems. Okay. Let me see you after the training. So yeah, guys, you can see almost the training is completed. Um, and like I said, don't expect performance from this model because here we have just done 10 steps. Okay, so which is very very less. Like you see, like even it is not 0.1% of the data set that you can see it from this epoch 0.03. Okay. So this is just to show how to fine tune your model. Okay. Other than this, there is no other intention for this video. Okay. So you can train it for a longer time when you have Colab Pro, or even in Colab for 2 to 3 hours you can train, maybe even 4 hours if I'm not wrong. Okay. So at the time you can just increase the samples and then run. Okay. So batch size can be increased. So with batch size 12, at least you can train one epoch in 3 hours. Okay. So that can be done. So now actually our training is completed. It is getting evaluated. The loss is getting evaluated. Okay. So we are getting 7.00 loss. That is fine. Okay. Followed by this, what is happening is that our model is getting uploaded in the hub. Okay. So finally the model is trained and it is pushed to the hub. Okay. So here you can see everything is uploaded. All right. So yeah, that's it for this video, guys. Thank you for tuning in. So if you like the video, please do click the like button. And if you haven't subscribed, do subscribe because like I said, there are a lot of videos being in the pipeline for NLP specifically. Okay. So yep, I'll see you all in the next video. Thank you.